Binary molecular compounds contain two nonmetal elements, and those nonmetal elements are going to form molecules. With the ionic compounds, we listed the metal first, the cation first, and then the nonmetal. In the molecular compounds, IUPAC has established an order in which elements should be listed, and this is the official order: carbon, phosphorus, nitrogen, hydrogen, sulfur, iodine, bromine, chlorine, oxygen, fluorine. I am not going to attempt to trick you on order of elements. I want you to know there is a particular order in which the elements are listed. There is a reason for why it's H2O and not OH2. Okay, H is listed in an element's name and a compound's name and formula before oxygen. Now, I also don't think that you need to memorize this list. There's a general rule that will work most of the time, and in case you haven't guessed, I'm rather fond of things like that. So we're going to go with the more metallic element first. More metallic element first. Like I said, it doesn't work all the time, but it works most of the time. How do you tell what's more metallic? It's the one that's closer to the metals on the periodic table. So if you've got a compound between nitrogen and oxygen, which one's closer to the metals? Nitrogen. So nitrogen gets listed before oxygen. So it's going to work most of the time. And I'm not going to get real hung up on that, but just so you know. When we name binary molecular compounds, they have two elements. They also have two words in their name. You name the first element first, you name the second element second. The second element acts like an ion in some ways in that it changes its name to "ide," just like the nonmetal anions did. It is not an ion. I think we do this because if we said, sulfur chlorine instead of sulfur chloride, how do we know that the person isn't just listing off two elements, sulfur and chlorine, and they forgot the comma? Now, commas save lives. Did you know that? Let's eat, comma, grandma, or let's eat grandma, right? Commas are important. But just people leave them out sometimes. And so we're changing the ending of the second element's name just to kind of draw attention to the fact that we're talking about a compound here, not a list of elements. Because the molecular compounds don't have ions, we don't have charges to tell us how many of each are going to be in a molecule. And so we need to tell each other with words. And so we're going to use Greek prefixes, numerical prefixes, to tell how many of each. And so these are the Greek prefixes, and you need to know these. You probably know a lot of them already. Mono means one, di is two, tri is three. A triangle has three sides, right? We know that. Tetra might be a little different. Did you ever play Tetris? How many little squares are in each of those Tetris blocks? 4. The name Tetris comes from the meaning of tetra, which is 4. The pentagon, the building with how many sides? 5. A hexagon has 6 sides. Hexa and 6 are also both the only ones that have X in their name. Hepta is just flat out weird. That's 7. Sorry about that. Octa, nona is a lot like 9, and deca, decade. How many years in a decade? 10. Okay, so these should be pretty easy to get down. This little blurb at the bottom, I actually had never heard of this before. Enea as the prefix for 9. Interesting. We're not going to do that. We're going to use nona. Now, I've talked to you about the chemist's bias against the number 1, right? We are also biased against the prefix for the number 1, mono. So the prefix mono is not used on the first element, ever. And really, it's only used on the second element to avoid confusion. So there's carbon monoxide and carbon dioxide. But there are some combinations of elements where there is no version with just, the version with one is all there is, and so they don't use mono. So what I would like you to do is I would like you to use mono on the second element only, okay? Because I think it's just a little too sketchy to have students trying to predict whether they should use mono on the second element or not. So we're going to go with mono on the second element, but I do want you to know that if it's missing on the second element, it could very well be okay. So let's practice these. By the way, this is the type of naming that students like. This one's easy, and then they try to use it for everything. You cannot say bi. We use di. Bi gets used in organic chemistry, but it means something very different, and so we don't use bi for two in general chemistry. So let's name these guys. Here we've got Cl2O5. So there's two of the first element. The prefix is di, and the name of this element is chlorine. So it's dichlorine. Those go together, dichlorine as one word. Then we leave a space, and what's the prefix for 5? Penta. Pentaoxide. Now there's kind of two ways. Sometimes you may see that they drop this vowel here, pentaoxide, and they'll just say pentaoxide. Either one is okay. So just be aware that you might encounter that. Any questions about that one? Yes? It's chapter 6. And then BR 308. What's the name of that? Tribromine octaoxide, or octoxide. This looks like if6, doesn't it? IF6. What's the name of this one? Iodine. We're not going to use mono on the first one. Hexafluoride. So the first element just uses its regular name and a prefix if there's more than one. The second element changes the ending of its name to "ide" and almost always uses a prefix. How about this last one, P4S10? Tetraphosphorus. Decasulfide. Any questions?
How do you tell the difference between the molecular compounds
And the metals? Or the ions? The ionic compounds? That's a very good question. How do you tell the difference between molecular compounds and ionic compounds? The presence of a metal. So if we look at these, chlorine and oxygen, bromine and oxygen, iodine and fluorine, phosphorus and sulfur, they're all non-metals. And if you got confused and were trying to name this as an ionic compound, and you started out with phosphorus and sulfide has a -2 charge, and then you look at phosphorus has a -3 charge. There's no way you can put those together and make a neutral compound because they're both negative. This is not based on ions. It's based on sharing of electrons. So two nonmetals, binary molecular compound. And it's important to be able to tell the difference because students like these numerical prefixes and they want to use them everywhere. Only with two nonmetals. Okay, only with two nonmetals. If it's got a metal in it, it's an ionic compound. Does that help? Any other questions? A lot of times you've got this little glitch that's holding up your understanding of everything else. And asking and getting that straightened out, and usually there's at least one, if not 5 people in the class who are also having an issue with that. Question? Binary molecular. They're binary because they have 2 elements, and they're molecular because they form molecules, they don't form ions. So let's write formulas from the names. Diphosphorous pentasulfide. So we need the symbol for phosphorus, and di means 2. So P with a subscript 2. Pentasulfide, penta means 5. So we've got 5 sulfurs. My S kind of looked like a 5 there. Try to make it. What about tetraiodine nonmetal? I4O, sorry, O9. Nona oxide, 9 oxygens. Tetraiodine, 4 I's. Okay, I4O9. Carbon monoxide. CO. Capital C, capital O. Not to be confused with the element cobalt. One's a metal and one's a poisonous gas. They're kind of different. This is one place where we always drop the second vowel. I'm sorry, the last vowel. Monoxide, not, say monoxide, because that looks like monoxide, doesn't it? Yeah, that looks really crazy. We always drop the O there. But again, I'm not going to try to trick you on that. We have bigger fish to fry. Sulfur hexafluoride. SF6. See, those seem kind of easy compared to all that ionic business, right? It's like, phew. Don't get carried away. Okay? 2 nonmetals. The only time you can use it. The other times you got to do it the other things. So any questions?
Will it ever on a test specify even molecular and those?
Probably not. Probably not. And that's one reason we're doing those worksheets. In lecture, I'm just doing each of them separately, but on the worksheets, it's giving you them all jumbled up, and it is highly suggesting, okay, figure out what it is first. You have to figure out, is this an ionic compound? Is it a molecular compound? Or is it an acid? Because that determines what set of rules you use. And that's a really important skill. So we're practicing the individual steps first. Any other questions?